All right, looking at combining functions together, we're going to look at the notation, and in each case, this is going to generate a new function, and sometimes the function is going to have some slightly different characteristics than the original two, but the first task is to understand what the notation represents. So suppose we're given two functions f and g, and right now we don't need to know what they are, just we're given two different functions. If I have this symbol here, where it's f plus g, that simply means that I'm adding f of x plus g of x. And this actually creates a new function by adding the original two functions. The difference, so f minus g of x, so that means we're going to take f of x and subtract g of x. And again, this makes a new function by subtracting. Okay, product f dot g simply means that we are taking f of x times g of x, and this also makes a new function by multiplying the two functions. And lastly, f over g really means that we are dividing those two, so f of x over g of x. And again, anytime we're dividing, we do want to state that we understand that we cannot divide by 0. So we're claiming that this can only happen if g of x itself is not 0, and that does make a new function through the process of division. So we are dividing the two new functions. The domain of these new combined functions will be the intersection or all values in common. In other words, they have to satisfy f and g in order for it to be part of the domain. So if there's any restrictions that occur in any piece, then we would want to exclude those given our domain statements. So anyways, all values in common of the domains f and x, f of x and g of x, is excluding any new bad values created by combining. That idea of when we combine them, we now have a new restriction that we didn't plan on having. That actually happens when we're dealing with the quotient of two functions. And if you kind of think about it, that makes sense, because if we weren't dividing already, now when we did the quotient piece, now we're actually dividing the two functions out. Okay, so now we're going to look at an example of this. So we're going to have an f of x is x squared plus 2 and g of x is x minus 7. Just for fun, let's kind of look at individually what if there's any restrictions. So f of x being x squared plus 2, it's not a fraction, it's not a radical, so it doesn't have any particular restrictions. G of x, also same thing, not a fraction or a radical. So they don't have any individual restrictions. And so most of the time that we combine these, I would expect them to basically have no restrictions whatsoever. So going through the mechanics then of this, f plus g of x means I want to take f of x, which is, let's see, I'll take f of x and I want to add it to g of x. Okay, so f of x is x squared plus 2, and I want to add that to the g of x, which is x minus 7. And I can see that there's some like terms with the 7 and the minus 2 that I can combine. And so our result then is x squared plus x minus 5. And the domain, so f didn't have any restrictions, g doesn't have any, and looking at the combination, it's also a polynomial, so there's no real restrictions on it. So we end up with negative infinity to infinity for that domain. Okay, the next example is subtraction. So I want f of x subtract g of x. Okay, and order does matter here, so you do want to make sure you put the right one in front of the other. And it's all of g that gets subtracted, so I'm going to put parentheses around that so I don't forget that it is all of g. Okay, so then because of that negative, I do want to distribute that in. So that's minus x plus 7. And I see some like terms with the 2 and the 7 again. And so this time I get x squared minus x plus 9. And as far as domain goes, f didn't have any restrictions, g didn't have any. The combination of that x squared minus x plus 9 doesn't have any restrictions, so it's going to be negative infinity to infinity. All right, f times g, so I want to take the product of the two functions. Okay, so I want x squared plus 2, and I want to multiply that by the x minus 7. And so here we're going to want to distribute that. So we get x cubed minus 7x squared plus 2x minus 14. And that would actually be our combination right there, because there's no like terms that we can deal with. And the original 2 didn't have any restrictions, and this combination doesn't have any new restrictions. And this is actually something you would expect to see. So if you're dealing with regular polynomial functions, you wouldn't expect when you add, subtract, or multiply to be any sort of difference. Now division, however, is a whole new game. So let me set that up. We got f divided by g of x, and again, order seems to matter with this one. So that would be x squared plus 2 up top, and then x minus 7 in the denominator. And so now we're dealing with the fraction case. In the fraction case, we want to set the denominator equal to 0 and solve. Figure out what doesn't make it equal 0. So add 7 there, and x cannot be 7. So if you think about it on a number line, you get an open circle at 7, anything before and anything after. So my domain then would be acknowledging that. So I've got everything before 7 and everything after 7 would be the domain there. And that's sort of a typical observation that will happen when you're dealing with quotient, and that you should end up with some sort of restriction because you're dealing with a fraction. Now let's change f and g to something a little bit more interesting. So let's make f be the square root of x plus 2, and then we'll just let g be x minus 4, and kind of go through the process here. So starting off with, let's sort of think about what would happen to f and g on individual basis. So since f is a square root of x plus 2, that means I want to figure out what's going to make the inside piece be greater than or equal to 2. Sorry, 0. Sorry about that. And I want to subtract out 2. So in that case, as long as we're greater than or equal to negative 2, then f will be satisfied. G, being a polynomial, it's not a fraction or a square root, so g will allow any number to work. There are no exclusions from the domain of g. Okay, so let's go through our steps then. So an f of x plus g of x for this first one. And f of x, we get square root of x plus 2 plus x minus 4. And as far as simplifying goes, there's not much that we can do there. Nothing really combines out, so I don't know, reordering, which really isn't a thing. Okay, now, as far as any new restriction goes, we know that f has to be at least bigger than or equal to negative 2. So as long as, and we don't really pick up a new restriction, so that would be the domain of this one. It's bigger than or equal to, so bracket negative 2 out to infinity. With the other next case, the difference case, so f of x minus g of x. All right, so that would be square root of x plus 2 minus all of g. So I'm going to put parentheses around the g that time just so I recognize that we are subtracting everything inside g. And I can see that we can do a little bit of simplify here, at least with the negative. So minus x plus 4. And that's about it, actually. Not really, I mean, reorder it if I want to, but that really doesn't make it any better than what we've currently got. So our domain then has to satisfy the restriction of the original two. And this one still doesn't add anything new other than negative 2 out to infinity. And that's going to bring us to our multiply case. All right, so f of x times g of x. All right, f of x is square root of x minus 2 times the g of x, which is x minus 4. Okay, and again, as far as simplifying goes, not much we can do. Maybe distribute it, but that's just going to make us write the square root twice, so I think this is perfectly fine, so we'll just leave it in that form. And the only restriction we have is the same initial one from the beginning. Okay, I'm sorry, I just caught my answers are still good, but I just caught a slight issue. That should be x plus 2, and way back here, that should be an x plus 2 as well. Didn't affect the domain, so all I had to do was change the minus to a plus, but I do apologize if I caused confusion there. Looking at the quotient case then. So quotient case, we want f on top and g on bottom. Okay, so that would look like the square root of x plus 2 and x minus 4. Okay, well now we've got, we picked up a new restriction. We still have that we can't have, or that it starts at negative 2 out to infinity for that domain. But now dealing with the fraction, I want to figure out what's going to make the denominator equal 0. And that's, of course, when it equals 4. So let's put this on a number line so we can kind of see this graphically. So here we're saying negative 2 is closed, and we want anything shaded bigger than it. And when we get to 4, we want that to be an open circle. And we'll keep shading around it. So that's what I want to specify as my domain then. So my domain is going to be bracket from negative 2 out to 4 with parentheses, union 4 out to infinity. And again, I notice there's two pieces here, so there's got to be two pieces in my interval statement.